And here we go. So first of all, I want to thank you all for joining me today. We're here. This is the first of a series of webinars that we hope to present on a monthly basis in 3 different time zones, one for the Asia Pacific, one for the North and South America, and one for the European region to try to fit within your regular workday. This one is going to be on debugging. And why would we do this? The real goal of some of these debugging features is to help you see calculations that are performed within the software, but you might not see all the details behind those calculations. You might just see the calculated value, which is really the primary reporting output, and makes sense for that to be the primary reporting output. But if you're trying to figure out if it's working, you need to see more, especially if it's something complicated, something with a lot of elements going into a complicated formula. Let's say a heart risk score with 3 or 4 elements that input to that. You're going to want to check and make sure it's working. And it's not so easy to do that if all you get is the final score reported back. So this is going to give you a little bit of visibility into looking at the calculations behind the scene that eventually make their way into the standard outputs. So the first thing we're going to do is we're going to open up an example model. And that example, first of all, before I get started, please, I've got everyone muted to keep the background noise down, but there's a chat window within the GoToMeeting control panel, and you can submit questions through there, and I will take them as I can as I reach little breaking points within the overall presentation. So in order to demonstrate this, we're going to take a model that doesn't have any debugging built into it yet, and we're just going to use this. This is the projects view, and we're going to use this example model, microsimulation cancer model distributions. So I'm just double clicking that, and this projects view and these example models are included with your software, so you can open these up anytime you want. And we're going to use this as an example, and when we generate output, it's going to go here to the console. And it's a little confusing because there's 3 consoles, but the calculation trace console, this element of their software right here, this is where the debugging output is going to be written when we configure the model to do so. So we'll keep an eye on this little area right here as it fills up with information that we want to see. So when we talk about the debugging options, there's really a few things to look at. First of all, this calculation trace console. But secondly, it's the tree preferences that you use to configure your model for debugging output. And you really have a couple of outputs. You can examine calculations for specific formulas. You could output every calculation, or you could limit the calculations that are written to that console to specific portions of your analysis. So we're going to look at those options soon. In fact, immediately. So here's our calculation trace. I'm going to go into tree preferences, and you'll see this on all different trees. You'll see the same things, but specifically what you may be used to dealing with these calculation type things or the display things, but right now we're looking at the settings down here, analysis settings, and specifically within analysis settings, the debugging calculation trace console or configuration. And you really won't have to worry too much about the stuff up here. The one thing that I do like to do is check this box, which means every time you run an analysis, get rid of all the output from the prior analysis and start fresh. But where we're going to focus on is really this, and to a lesser degree down here. And we'll start by setting it to show all output for the analysis. So basically, show me everything that's happening behind the scenes. If I set it to none, obviously you'll get no output. And later when I set it to selected outputs, then we'll have to identify the specific elements of the model that we want to see in the calculation trace console. So let's start by setting it to all. And when you do all, you really can't run a huge microsimulation. If you run 100,000 trials or 10,000 trials and show all output, it's going to take 3 or 4 hours, and it'll probably crash, because eventually there's going to be so much data over here in the console that your computer won't be able to handle it. So just be careful when you set it to all, especially with a simulation, whether it's probabilistic sensitivity analysis or patient simulation, microsimulation. If you run too large an analysis, it will not run, and you'll start to get memory errors. So I'm going to set it to all, but then I'm going to run a fairly concise and small analysis. So we've got that set to all. I'm going to click OK. And I haven't really changed the model. The model, I'm just for a second, I'm going to minimize this. The model is just the same as it was before. It's a 3-state Markov model that's run that requires patient simulation because it's using trackers with 2 strategies. I don't have to change anything. That all I have to do is do the tree preference and say I want to see the output. Now I'm going to run an analysis, and let's show the console again. And I'm going to select the decision node, and I'm going to choose this option for individual patient simulation. But I'm definitely not going to run 10,000 trials. I'm just going to run 2 and let it go. And what you're seeing is you're going to start to see all this output generated as those people run through the model. And you may notice that it was actually pretty slow, even though it only took a few, 10, 15 seconds. But for 2 trials, that would have finished in, half a second or a second. But because all of this output was written, that slows down the analysis. Now let's take a look at the output. So I'll just kind of move this over so we can see a little bit better. And what does it start with? It starts with the distributions, right? We need to know the distributions, whether they're sampled or whether, in this case, we have a few distributions that are not sampled because they're PSA distributions, which are not sampled in this case. But here it's evaluating the parameters of the distributions, and it's getting the means for a couple of them. And if I scroll down, finally, when all the distributions are set, now it's ready to run the first trial. So here I'm running trial 1 in strategy 1, and it's the first stage. And we're clearly not going to go through everything, but what is the first thing it has to do when it's interpreting a Markov model? Is the termination condition true yet? Well, it's not, because the stage is not 20 yet, right? Stage is 0. So yes, I'm going to run that cycle. And because it's the first cycle, I look at the initial probabilities for the 3 states back here in the model, right? The initial probabilities are 1, 0, and 0. So everyone has to go to local cancer. So of course, that patient goes to local cancer. Now, what happens at these Markov nodes and chance nodes? The first thing it does is calculate the probabilities, and then it draws a random number. And it sends the person to one of these spots based on what that random number is. Now, because this is 1, it doesn't really matter what this random number is. It's going to be there. But let's say this were 20%, 30%, and 50%. Then if I drew a number here between 0 and 0.2, you'd go to the first branch. Between 0.2 and 0.5, you go to the second branch. And above 0.5, you go to the third branch. So this random number is really important in terms of which way the patient's going to go at each chance or Markov node, but it's not that important when it's 1, 0, and 0. So then what happens next? Now the patient's at the local cancer state, and we have to calculate the rewards here. So here it is. Calculate the utility rewards. Evaluating that variable that's here. U local times 5 because of half cycle correction. Boom. There's utility for the first cycle. There's your cost for the first cycle, or state cost for the first cycle, right? And then we continue. And now what does it have to do next? Now we have to figure out whether that patient's going to die from background mortality or survive background mortality. Well, it can't do that without first determining what this probability is. And so here's the calculation of that probability. Here's the drawing of the random number. And here's the progression of that individual to the survived background mortality. And now the patient is here. And then it goes through the same process to determine whether it's going to go to each of these. In this case, I won't go through all those probabilities. In this case, they random walk to stay here. And when you random walk to stay here, that means you go to local cancer for the next cycle. And boom, now that person is going to be back at the local cancer state here. Oh, I went too far, sorry. Here to start the next cycle. And that process continues and continues until the person either reaches the end of the time horizon, which is 20 cycles, or dies and reaches, in that case, an absorbing state. Now, if I scroll down enough, keep going, boom, there's stage 2, stage 3, stage 4, right? That person's still alive, stage 6, stage 7, etc. And now you see it went back to stage 0. Why? Because they died. So this person died from an adverse event. That is a node somewhere in here. And now that same trial 1 is sent into the second strategy. And you'd see the same kind of output for the second strategy. If I kept scrolling down to get some more, remember I only ran 2 trials. Now I'm at trial 2, strategy 1. So I don't need to show more elements of over here for this part of the model, but you see it's really output everything that happened as each of those 2 individuals went through each of the 2 strategies. Now I just want to double check and see if there were any questions before I continue. Trying to get to there. Okay, no questions. So I'll continue with the next part. So that's if you want to see everything. But as we know, it's not really realistic to run a really long analysis and see everything because it's just too much output, and none of us have supercomputers on our desks that can generate lots and lots of or handle enormous amounts of output. I see that someone's having trouble getting to the console. I don't really have time to make this a interactive session, but if you want to call me later today or tomorrow, I can help you with that. So now I want to show you a different way of using this, where we just look at individual elements, because it may be that you don't really need to see everything. What we really want to see is something specific, something that's complicated, something that's complicated that allows you to just focus on that calculation and run for, let's say, everyone. Now, with respect to this, there are finds and stuff like that. So you can right-click and do a find, and you could look for, random, and it'll just go to the next random, and you can keep finding. You can also copy this to a text file, or if you want more flexibility in terms of parsing through this data. There's other things you can do, which I won't really cover now, but they are included in the help files. But now let's look at the same model, but let's not try to output everything. Let's just output a subset of the output. So I'm going to close this analysis, and I'm going to go back to tree preferences. And instead of doing all, I'm going to do selected elements. And instead of doing every trial, every individual, I'm going to limit it to just the first 2. And it wouldn't have to be the first 2. I could have potentially run this, let's say, with seeding on it, identified an outlier person, someone who, let's say, accumulated a very, very large cost. And I'm trying to figure out how could that person have had a cost that's 50% bigger than someone else. Well, I could say, well, I want to see trial 8001, right? To 8002. I could look at those 2 trials. So I could run the whole analysis and focus on the outlier and say, what happened to that outlier person? How did that happen to them? But I don't need to do that here. I'm just going to do for the first 2 trials. And because I selected elements here, not all or none, I'm not quite done. I have to choose something to output. So my tree preferences are set, and I'm going to focus on one distribution and one variable. The variable I'm going to choose is p background depth, just because there's a few different calculations or elements to that calculation. So you see this debug. I'm debugging the root node definition for this variable. So every time that variable is referenced, I'm going to see output in the console. I'm also going to look at the start age, debug the start age distribution for each individual person that's sampled as they enter the model. So I've just selected those 2 elements for a review in the console, and now I can go back and I can run the whole analysis. I'm going to run microsimulation. I'm going to run all 10,000 people this time, and I'm going to click begin. And it doesn't slow down the analysis once I get past the first 2, because I'm not writing anything for other than those 2 people. And the only elements that I wrote for those 2 people were the 2 that I selected. So let's go back to the console and take a look at what we've seen. Okay, so here's trial 1, and here's the start age that was generated for that first person as they entered the model, 31. Now, I think there's a bug here that it's sampling twice. I'll have to look at that later, but this is the one it's going to use because it sampled it a second time. It shouldn't have to do that, but this 46 is going to be the age for the first person, right? So that's the distribution I asked for, and this is the probability. Oh, looks like I clicked the wrong one. Let me rerun that. Sorry about that. I must have clicked the wrong one. I'm going to come back here, and the variable that I wanted to choose was p local to dead. Not p local to dead, was p death background. So I checked one too high. That's why I got p local to dead instead, which is very simple. It's a fixed value that doesn't really help us much. So let me just run it again. I'll close this one. I had checked the wrong box. Run it again. Now I'm getting the actual one that I had wanted to select the previous time. And let's go back to the top. And here's our 46-year-old entering the model. And when that individual got to this part in the model where it needed p death background, well, where is that? It needs it right here, right? We need this value. We can't know which way to go until we know this probability. And sure enough, the person was 46. No time has elapsed because it's the first cycle, so there's still 46. And this is the probability that came out of the background mortality table. And if I can proceed forward just a little bit more, right? Now it's stage 1. Now the current age is 47, right? 46 plus 1 annual cycle that's passed, they're 47, and now the probability of death has changed. And as time goes by, right, up here with stage 8, that probability has increased a little bit each cycle because the person's aging and the background mortality is increased. So you can use this for anything. These weren't super complicated models or super complicated formulas that I'm showing you, but what's important is the technique. When you have a formula and you've created some kind of definition that's complicated here, you can use this to see the calculation, not just the calculation, but the calculation once, but every time it's executed, if that's what you want, under different circumstances of different strategies, different people, right, different stages, and you can check that and make sure it looks like it's calculating correctly. Okay, now there's one last, I'm going to just, before I go on, I'm going to check for questions. I see a couple of questions have come in. So let me look for those. So we have a question. Okay, so how does the TreeAge calculate the random walk? I think I passed through that where it said basically, let's just imagine a 50-50, 50% here and 50% here. When it generates a random number, it's going to be between 0 and 1. If it gets that random number between 0 and 0.5, the person will go this way. And if it's between 0.5 and 1, it'll go that way. And that's true no matter how many branches you have. It will split that total values between 0 and 1 into fractions based on each of the branches and the probabilities of those. And the random number sampling will tell TreeAge which way to send that patient. So that's how that works. Another question was, I'm going to read the question. You made an example of selecting trial 8000, 8001 to evaluate an outlier. If you're doing micro, how would you go back to see which is the outlier? Well, the first thing you'd have to do in that case is you'd have to turn seeding on, and I'll show you that quickly. If tree preferences, if you have under Monte Carlo options seeding, if you have seeding on, then you're going to get the same results every time. And so that way, if trial 8000 is the outlier, it will be the outlier next time, and I'll be able to see that. Now, if seeding were not on, then you'd get a different set of results, and it would be harder to find the outlier and then look at the details for that outlier, because it would be a different person potentially. So the seeding is how I can get repeated same results every time and focus in on something that could be a problem. So that was another question. And then there was another question, can it be used for standard Morcart? Absolutely it can. If I just, by doing microsimulation, it was easier to see some of the details, but this one really shouldn't be run with microsimulation or with Markov cohort analysis. It should be run with microsimulation. But if I change the tree preferences back to show all rather than a limit, and I just ran the cohort analysis, nope, I'm not getting any out. I should get output. I'm going to have to play with that a little bit, but it definitely can be used. I must have said something wrong. Tree preferences. Oh, I set it to none. That's not very helpful. Let's try all. And now you see the same kind of output is generated for a cohort analysis that I generated via rollback. You won't see the same kind of random walk. You're going to see calculations of rewards and probabilities and the splitting of the cohort. But in many ways, the cohort analysis reports, these reports are nice for seeing that data. So this is the kind of calculated data, and you could use this to supplement that with additional calculations that generated some of these numbers. So you're definitely not limited to only doing that for microsimulation, although that is sometimes the place where it's most valuable. I think I got to all the, oh, I got another question. So with the seeding, if you're seeding on, if you look at the results, the all data report will show you the results of each individual. So I could say, I'm making this up, but let's say I say this 835,000 seems really high, seems higher than anyone should get to. Then I could focus on trial number 7, and I could use that to focus on the details of the calculation. So that's how you'd figure out which is the outlier, by looking at the individual results, whether this was a PSA or whether this was an individual patient simulation. Identify some result that seems out of whack, and then run the debugging for that individual to see what happened to them. So I think I've got to all the questions, so I'm going to move forward with the next thing, which is using the debug functions. Now, the debug functions are described in the help files. In here, it's I'm going to do a search here for debug functions. These are a little bit harder to work with because you actually have to build them into the model. The other ones, you just basically had to just turn it on. Right, here's the debug functions. You see there's debug, turning it on, turning it off, export the data to the file name, write stuff to the console. This one writes stuff to the console even if debugging is turned off in tree preferences. This is something I'm going to show you how to use. So I'm going to open up another model, specifically this parallel trials queue global tracker. Now, I don't have a lot of time to go through that whole model because there's a lot of complicated stuff in there. But what's interesting about this model is that it has a competing resource where people wait for the resource and they may get it and they may not. And this is new functionality added in 2018. And if I turn on through the tracker properties, this hidden one, we've hidden this so it doesn't distract you from the important stuff in the model. But what this is basically doing is at important points in the model, it's saying, where am I? Right? There are important things that I wanted to test and make sure this was working correctly. And I say, okay, I'm waiting for the resource. That means I didn't get it. Or I did get the resource granted. So I've just used the debug write force to write to the console important messages that I needed to validate that this model was doing what I expected to do. So now I'm going to go back and I'm just going to run one strategy. Let's go back to the console, and I'm going to run one strategy, 100 people. And now it's done. And let's go back and see what we wrote. Using the debug write force. It said, okay, all these people were waiting for the resource, and of those people waiting for the resource, these 2 people got it, and all these people didn't, because there were only 2 resources available. Now, I don't want to get into all the details of how that's functioning with the parallel trials. We will, at some point in the future, do a parallel trials resource constraint queuing kind of model, a webinar on that. But for me to validate that this was working, That's what I did. I used the debug right force to tell me where the individual trials were at different point in the model to validate that the right number of people got the resources and that they were released, and when they were released, other people got them. So that's the third way to kind of generate a lot of output. One is show everything. One is show individual different elements of the model, and the other is to literally use functions to write to the output. And one thing that's very nice about the debug functions is they all return 0, so you could literally put them anywhere. I could put, right under a probability, like here, I could add a debug function here plus debug whatever I wanted to do. I know that's going to return 0, so it won't change the results of the model by me adding additional elements of output that I want. So that's everything that I wanted to go through today. So I just want to check and see if there's more questions. If there's any more questions that I've missed. I don't see any questions. So I just want to point out on our website here that we have a few more webinars coming in the near future. We'll do an infectious disease model in each of the 3 regions in mid-March, and then we'll do some stuff on Markov reporting in April, and we'll do something else in May. We just haven't quite figured out what we're going to do. We want to continue to keep this series going to keep you abreast on the new and sometimes old, sometimes new features that you may or may not be using. But with that, I'm gonna close it out. And of course, in addition to webinars, there's also training classes. So if you want to do on full 2 days of training, there's a public training calendar which you can determine if you'd like to go. I'll be in Raleigh-Durham next week teaching, but we have a few more in Melbourne, London, Tokyo, Baltimore, and Boston scheduled, and we'll probably schedule something else later in the year as well. And that's all I have, so I'll just look and see if there's any more questions before we close. No questions. Anyway, thank you all for joining me today. And then if you want to contact us afterwards, you can reach us at 413-458-0104, and then a 2 for support, or you can send email questions to support@treeage.com, both of which will come to me. And I just want to thank you all again, and I hope you all have a wonderful day. Thank you.